Hello, I'm Arunabha Ghosh. I'm the CEO of an independent policy research institution called the Council on Energy, Environment, and Water. Thelma Krug has already talked to you about why we are even thinking about issues about climate altering technologies, what is happening in terms of emissions, what trajectory the world is on, and why we need to be thinking about alternatives and in terms of our responses at the planetary level. I am going to talk to you a little bit more in detail about the types of technologies that are being considered, but even more so about the specific challenges that emerge in terms of the research around them, as well as the governance issues that emerge as a result. The Council on Energy, Environment, and Water is an independent research institution. We are based in New Delhi, in India, but we work across emerging economies across the world. And we've been working on the governance of climate altering technologies and approaches for about a decade now. So what are these technologies? In broad terms, it's useful to think of them in two big buckets. One bucket is called carbon dioxide removal. In this bucket, we are basically talking about trying to reduce or remove the carbon dioxide that's already in the atmosphere so that we can reduce the amount of warming. Because once the molecules are in the atmosphere, they stay there for a very long time. And therefore, even if we stopped emissions of greenhouse gases today, we still have to deal with all the carbon that's in the atmosphere. And that's why removal of carbon dioxide becomes one of the climate altering technologies or approaches. Now, within that, you have various different options. Some are talking about what is called ocean ion fertilization, where you increase the population of phytoplankton, which then absorbs the carbon from the atmosphere and then sinks to the ocean floor. There are other approaches such as enhancing the natural weathering of rocks. So you increase the alkalinity of the oceans. Or you could do something that we tend to do in general, plant trees, afforestation, to suck more carbon out of the atmosphere. There are other approaches of using chemicals towards chemical processes to directly capture carbon dioxide from the air and store it. Or we could burn biomass and then capture the carbon dioxide. There are these various different approaches that are being considered or under research. And then there is this other category, what is called solar radiation modification. And here, the point is not to get carbon out of the atmosphere, but to prevent heat reaching the Earth's surface. So can we reflect sunlight back into space so that less sunlight reaches the Earth's surface, gets trapped by greenhouse gases, and warms up our surface temperatures? In that regard, again, there are various technologies or approaches that are under consideration. One is called marine cloud brightening. So brightening or making the clouds over our seas whiter so they become more reflective. Others talk about injecting aerosols into the stratosphere. And those tiny particles then create a sort of envelope around the stratosphere where they would be able to reflect back sunlight before it even penetrates the atmosphere and reaches the Earth's surface. Now, let's be very clear. None of these are available, proven technologies that can be deployed. And that's why a lot of challenges emerge in terms of what are the, how do we even think about the research associated with these different approaches, and what are the governance challenges associated with them. So in the rest of this presentation, I will outline for you a few clear challenges that emerge, at least to my mind. Challenge number one is how do we evaluate these options while we consider the precautions associated with them? The graph in front of you shows two different metrics along which these different options have been evaluated. Affordability, how relatively cheap is this to do, and how effective are they in terms of either removing carbon from the atmosphere or in terms of reflecting sunlight, or reducing, in technical terms, the solar insolation that reaches the Earth's surface. And as you can see from this graph, these different technologies are plotted in different places. Some might have high affordability, but are not very effective in terms of, say, sucking carbon dioxide out of the atmosphere. Some might be very effective, say, capturing air, directly capturing CO2 from the air, but might be very, very expensive. Here you will notice that injecting aerosols into the stratosphere is kind of, at least by some guesstimates or estimates, occupying some sort of a sweet spot of where there's high effectiveness as well as reasonably high affordability. But the other thing we have to keep in mind while we are evaluating these options is, should we focus more on sort of chemical or technological solutions, or should we focus on more nature-based solutions? Should we focus on planting trees, or should we use enhanced weathering or direct air capture? Should we put particles into the stratosphere, or will we think about whitening our surfaces here on Earth? So these are some of the critical concerns that not just scientists, but society at large has to consider. The second big challenge is, even if we had enough research going along these lines, what are the risks? And I categorize these risks in two buckets: material concerns and ethical concerns. Now, the material concerns are centered around risks that you can measure, or you hope you can measure eventually. We right now don't have very good knowledge about how aerosols will operate or interact in the stratosphere. We don't know well enough what would be the impact on biodiversity if we started reflecting sunlight back into space. Or what would be the impact on agriculture and ecosystems if we took up a lot of land to grow crops that we would just burn to capture CO2 rather than grow crops to feed people. We don't know enough about how it might impact rainfall in different parts of the world if we were so-called dimming the Earth's sunlight. We don't know whether it would thin out the ozone layer even further or create more acid rain. There's another concern, especially with solar radiation modification, about a termination effect. That what if we started such an experiment at a large scale, at a planetary scale, and lowered temperatures, but then stopped after, say, 50 years or 75 or 100 years? Would temperatures bounce back even very rapidly? Then there are concerns about, could just a few countries go ahead and do it on their own, or even a few groups of scientists? What kind of social and political concerns would emerge as a result? I live in a developing country, and many developing countries have a concern about what would be the localized impact if we did stratospheric aerosol injection over the Arctic. Would it impact monsoons in the tropics? These are concerns, again, that emerge. Similarly, there are ethical concerns. Some are completely opposed to interfering with nature at a planetary scale, that this is human hubris that simply should be stopped. Others are opposed to the possibility that these technologies could be commercially controlled and profiteered with. The bigger ethical concern is, would this reduce the incentive to mitigate emissions? If someone knew that we have a plan B, so to say, to fix the Earth's temperature overall, would we stop focusing on the important, urgent need to mitigate our emissions? What if someone went ahead and did this? Is there an ethical concern about others free riding on others' efforts? But the biggest ethical concern to me is, what is the intention behind the research? If a group of scientists are working on this to save the planet, that's one thing. But what if there are rogue nations? What if there are rogue groups of collaborators? We have to understand that we can't imagine, as Oliver Morton has said, can't imagine change without imagining the means that you use to change the planet. And you can't imagine these means without imagining the motives. And what would happen if there were transporter impacts? Are we even looking at future generations and what consequences they might be dealing with of our experiments? Beyond those kind of material and ethical concerns is a third challenge. How do we establish what are the thresholds of research and deployment when we think about climate altering technologies? One sort of threshold is that we can simply be doing this research within our laboratories. We could be modeling using our computers. Some of the most powerful computers in the world could be networked to look at the interactions of particles in the stratosphere and how that might impact um, temperatures. But what if beyond a point we need to experiment in the field? Small experiments of aerosols being injected into the stratosphere or brightening of clouds. But our small experiments, some scientists would argue, are not good enough to gather sufficient insight as to whether these are effective technologies or what are the downsides and the risks. And therefore, we have to think about what kind of governance do we need with large scale experiments? Should we govern just the delivery mechanisms? The photograph here is of a experiment being designed in Harvard called ScopeX, where a balloon will go up into the stratosphere, and then it would create a wake via a gondola going back and forth and a little bit sideways, within which some particles would be injected. But the idea is more to test this engineering. Should that be governed, or should we only govern the spraying of particles? And then the big question is a large-scale experiment any different from deployment? And therefore, how do we ensure there is precaution established at each stage of the research? Which brings me to my last three challenges. Who might deploy this? Well, to do this, we have to ask ourselves why you might do it. Is it a last resort to a planetary emergency? Or is it a first resort that some high fossil fuel consuming countries or provinces might decide to go ahead with? Is it to simply buy some time while we figure out our mitigation and adaptation strategies? Or is it a response to a very localized emergency like a severe drought or heat stress or loss of agricultural output? On the incentives, it is clear that if certain technologies are relatively cheaper than, say, converting the entire world's energy system to renewables, then there might be incentive to go ahead with this. Or it could be simply that countries might signal that they will go ahead with climate altering technologies if the rest of the world does not act more robustly towards emissions mitigation. And some might have an incentive to just establish a technological lead, or because no one else is coming to help them in a climate emergency. But the who question is important because these technologies are diverse enough that they could be either done by privately funded research or by a small group of countries or by a few countries that collaborate, or a single large economy acts alone, or even a very small economy, a small island state faced with a climate emergency says or offers its land or its territory as, using its sovereign powers to invite scientists to go ahead and experiment. And that's why I raised the question, is national governance at all going to be enough? Hence, challenge number 5. Currently, there's a very thin layer of international governance on climate altering methods. There are some treaties like the Convention of Biological Diversity, which has established a moratorium on geoengineering activities. They call it geoengineering activities without any scientific basis. There are some international regimes that are applicable to particular methods, such as the London Convention, London Protocol that would apply on ocean fertilization, or the Montreal Protocol for aerosols. Some are referring to specific substances, and some are limited to specific geographies, such as the Convention on Long-Range Transboundary Air Pollution that's limited to Europe and North America. The big question is, what kind of governance functions would any of these institutions perform? And hence we have to, as a global community, think about, do we choose ad hoc codes of conduct, which would give us flexibility and which would help us to rapidly come up with governance codes? Or do we have national level governance regimes? There will be sovereignty over the research programs within your territory, but there's no international monitoring of that then. Or should we adapt some of these existing treaties? Or would that add to the overburdened agendas of these regimes? Or do we need to create new treaties and new organizations to fill the regulatory gaps? But this will take time. The big point here is that if we are willing to contemplate technological interventions at a planetary scale, then we also have to begin to contemplate what human interactions would be at a planetary scale. And the minimum that we therefore need to do is my challenge number 6. We need to have transparency to reduce risk and build trust. It's a common principle across international research. We need transparency about the research idea and methodology, about any kind of outdoor experimentation, about the funding, so that we establish motivations and intentions, as well as, of course, of the outputs and the assessments that we have. To do a minimum level of transparency, we could be thinking about a combination of self-reporting by research groups or by countries, as certain countries have already established, and there are certain protocols that exist in international regimes. Establish peer review and consultations amongst the scientific community, but also community at large. Have national research platforms so that all of this can be governed at national level. Have international assessments, maybe even by non-state actors. There is the C2G that is hosting these series of webinars. There's my own institution that has hosted a number of seminars and conferences on this matter. So it's a combination of bottom-up monitoring and top-down enforcement, maybe. Which brings me to my final point, the challenge number 7. I think at some stage we have to think about how do we design international research programs on this so that we limit that problem around ethical and material concerns, reduce some of that risk, increase some of that trust. And we can do that by pooling our research capacity across countries, having flexible funding in kind and in cash, establish clear lines of responsibility and liability, establish clear protocols on sharing of intellectual property, or making all of this data available for everyone to consume and analyze, and design the institutions so that any kind of rules are established up front and disputes can be resolved. And this slide shows you there are many precedents from other international research programs, whether it's in agriculture, in nuclear fusion, in particle physics, and so on, in the human genome program, that you establish a lot of these steps to create a genuinely collaborative and legitimate research program. I'm going to close by this thought. Climate altering technologies occupy, in my mind, both the rarefied world of climate science, but also a very messy world of geopolitics. And right now, we have not established any way of legitimately weighing the risks of not acting enough against climate emergencies and the risks that might emerge from deploying controversial climate altering methods. This is not just a technical debate amongst scientists. It is, in my mind, high politics. And that is why we have to get involved in this conversation, because we have no means today to govern this uncertainty. Thank you very much for your attention.